Hello friends, let's start our today's practical, which is about related to Newton ring. In this practical, we will find the wavelength of the light, the source light. In this practical, we have a source as a sodium lamp, so we will find the wavelength of the sodium light here. Let's start our practical. So basically, Newton ring is based on the thin film interference phenomena. We all know that what is interference. Interference is the superposition of light waves coming from any two source. This is based on this interference of light with thin film. Now, what is a film is said to be thin film when its thickness is about the order of one wavelength of visible light, which is equal to be 5 nanometer. Now, the film should be the thickness of the wavelength of visible light, which is 550 nanometer. That then only we will be able to get the interference patterns. It is the theory written here. So I want to tell you something about some important topics here, that how we are getting the interference pattern. We are getting the interference pattern due to this reflected light and this reflected and the refracted wave in this system means draw the interference fringes. How? Right, when a wave is reflected, incident wave is reflected from the thin film, it has a phase difference of pi, and when it is refracted from the thin film, it has a phase difference of pi. So having a phase difference between reflected and refracted wave, we get a phase difference of pi, and that's why this produces the interference fringes. Now here the conditions have been written about the constructive and the destructive interferences. So this mu2 and these are the conditions. So you may find that these are the conditions where m is the mth order fringe, and it is for destructive means dark fringe, it is for bright fringe. Now we have to study about the Newton's ring, that how these are formed. So in this basically we need a light source which will emit light rays perpendicular. Our setup here setup contain a glass slab, parallel glass slab, and one plano convex lens. Here the thin film used is air film, the air between this plano convex lens and this glass slab. So and the incident ray fall on this plano convex lens. Some ray are get reflected, means ray 1 is reflected, and here you see that this ray after reflecting from this are refracted here. So this reflected from the lens and this refracted from the lens will produce the interference fringes. So the basic condition for the means dark and bright fringes are this in Newton ring. So it is the condition for the dark fringe and it is the condition for the bright fringe. Here one question arises that why these fringes are circular. So the reason is here that when you move from O to A, means from center to outward, the thickness of the thin film increases and it remains constant at a particular circular perimeter. That's why we are getting circular fringes. One more question arises that why the central dark is central spot is dark. So it is the reason that see here that here the thickness of the air film is very small. It means negligible. So the phase difference between the reflected and the refracted will be not be there. So we get here destructive interference, and that's why we have a circular dark fringe. It is the radius of the circular dark fringe. We have use this formula to calculate this. Rm means mth order circular dark fringe. So radius of the mth order circular dark fringe is under root m lambda, where lambda is the wavelength of the light and r is the radius of curvature of this lens, plano convex lens, and it is the radius of the mth bright fringe. From this formula we can see that that radius of the mth order dark fringe is directly proportional to the radius of curvature of plano convex lens. So from this experiment we need to find the wavelength of a sodium light. So how will we find that? Here this is the formula we use here. The formula is lambda is equal to dm plus p square minus dm square for pi. Now what is this? Dm means any mth order dark fringe diameter. It is a diameter here. So let take an example that we are taking the diameter of the second dark fringe. So dm will be d2 square, means the diameter square of diameter of second dark fringe, and dm plus b take any other dark fringe, means 3, 4, 5, 6, any other greater than this, take any other dark fringe. So we are taking, like suppose we are taking 4 number, 4 dark fringe, so here it will be d4 square. So what is the p? P is the difference between the this m plus pth order, and m means how many dark fringes, means how many, what is the difference between that fringes, 2 and 4. The difference is 4, so here it is the p, so 4pr. Let's move to our simulator now. How it works, let's see it. Now moving to our simulator, we start with simulation. It is the microscope here. Here we are having the measuring scale. It is the measuring scale here. It is a microscope, and you will see from here, and you will get the interference pattern here. So here the select the medium means what is the medium between the lens and the slab. So we have air as a medium, and light sources are sodium, as we have told earlier that we are using the sodium light to calculate the wavelength. So now coming to the least count of this, now let's see that this 1 unit, 3 to 4 is 1 unit. It is divided into how many units? Means it is divided into, and into 20 units. 20 units this, and this it is our vernier scale, and it is divided into 20 units. Its least count is must be 0.001 centimeter. Means what might be this? It's the unit. So it least count is 0.001. So let's start our simulation. We turn on the light. You see that this is our fringes pattern, and it is formed here. We can only see it by this microscope, or not our naked eye, so we are using this microscope. So starting our, we have to focus this, like see now we are at the center. This is the center of the pattern. Now we are moving to means we are moving to our right, and then here by stopping here. Now see, you will see that we are at the boundary of the bright fringe and also the dark fringe. So from here we are getting the one side measurement of the boundary of a circle. Now we don't have to use this central fringe. We should start with r d2, means dark second order dark fringe. Now we can see that as it is 2.5, it is 3, it is 2.9, 8, 7, 6 and 5, it is 2.5, and it is 2.55. We can see that easily that it is now it is correct, that we can see that it is 2.55. so it is matching with this 0, so we can say that it is fully 2.55. It is our one side measurement. Now we will get to other side in the left side, and then we take the another second order. Here we will measure another dimension. Now it is 2.5, it is 2.4, it is 2.3, it is 2.35, and then we will compare from it that where it is matching. It is matching with here 2.2. So it was 2.3, 2.35, and matching with 2 means 0.20. We should add 0.20. So it is 2.37.02. We are adding point multiplying with points, as its least count is 0.01, so it is 2.35, so we are adding 0.02, so it is 0.37. So it is 2.37. Now from as we had taken now from the earlier reading, and then this one reading, we should subtract them, means right hand side and left hand side, we should subtract both of them, then we will get a diameter of the second order fringe. Similarly we will take another for fourth order, fifth order, sixth order, 10th order, and then we will put it in the formula, and we will get you must take I will say that you must take the up to 5 order minimum diameters, and then put them in the formula, and then you will get your desired answer.